Right, so back for another OMG additional chemistry, and today we're talking about the fire triangle and combustion. So to get started, let's go through the two different types of combustion. So they are complete combustion. Complete combustion involves burning a fuel, an alkane, so something without a double bond with oxygen. This produces energy, which we then use to power our cars, fly our planes, so it produces energy. Hydrocarbons, just a type, an alkane is a type of hydrocarbon. Use oxygen, burn to produce energy, plus water and carbon dioxide. Okay, so carbon dioxide then contributes to the greenhouse effect if it gets into the atmosphere. In complete combustion then, still burning an alkane, so it's an alkane with no double bond, but there's not enough oxygen. Okay, so the problem with this then, still produces energy, not as much energy per amount of hydrocarbon as complete combustion, but unfortunately also makes carbon monoxide and water. So then we kind of use that then, combustion is part of the fire triangle. So the fire triangle is three parts to our fire triangle. One part can't just start a fire, so you need all three. Okay, so that's why it's quite easy to think about putting out fires, because you need three parts. You need oxygen, heat and a fuel. So you need something to burn, you need heat to start it, and then you need oxygen to keep it combusting. So can't start a fire with only one. How do we remove oxygen? The main way we use oxygen is to use a fire blanket, so it smothers it so no oxygen can get in. Carbon dioxide extinguishers, again, they force the oxygen out, and closing the doors. Okay, so that's how you remove the oxygen. So that would put out the fire, because you need all three to start a fire. Fuel then, often we use a fire break, which means cutting down a section of a forest so the fire will stop because there's no longer a fuel, and sometimes we use fire resistant materials. Removing heat then, heat's probably the most common one to try and remove. We could use water or we could use foam. And then we often talk about, because obviously combustion involves using alkanes, which are can be petrol, can be diesel, etc. So how can we come around that? So hydrogen as a fuel. So you can use hydrogen as a fuel. What you need to do is you burn hydrogen with oxygen. So we're still using oxygen to burn it, and this produces water, but it also produces energy. Big problems with this, okay, is that it's very explosive, really hard to store and transport. Okay, so it's really hard to store and transport the hydrogen and the oxygen. It needs to be in pressurized cans at about minus 250 degrees, so that's quite hard temperatures and pressures to maintain during transport. Hydrogen is hard to produce from pure materials, so there's not a lot of hydrogen in the atmosphere. You kind of have to come up with a way of making hydrogen to produce water in the cycle. Burning hydrogen produces no carbon dioxide, so that's the big win here, is something that doesn't produce carbon dioxide. What we use though, we do use a little bit of electricity, which will burn a crude oil, so could potentially produce carbon dioxide, because it's actually a type of electrolysis. So what you do is you use electricity to split the water into hydrogen and oxygen, and then hydrogen and oxygen can then combine again to make water, which also produces the energy. So it's a never-ending cycle, but there is a little bit of energy required to produce this hydrogen in the first place. And we did do this we watched a video of this practical, okay, but measuring how much heat energy is released from certain fuels. So you can put fuels in here. It's normally alcohols like ethanol, methanol, propanol, stuff like that, and we set them on fire. We measure the temperature of the water before, and then we measure the temperature of the water after. Okay, normally it's a set temperature change, so we go from normally 20 degrees to 40 degrees. What we're looking for is how much fuel has been used, so we need to measure the fuel before and the fuel after as well. Okay, so how much fuel is required to take that temperature change, normally from about 20 to 40. Okay, inaccuracies with this, heat is lost to the surroundings, so heat's been lost here and here. It's not actually heating up the water, so it'll take longer, essentially use more fuel than it would. Uneven spread of heat in the water, so you are heating up this section here. That means that if your thermometer is a bit higher up, this section here is taking a little bit longer to get heated up. The thermometer, this is only a plain thermometer. If you had a digital thermometer, it'd be more accurate because it's got higher resolution. So, same kind of thing again. Pause the video, have a go at the questions. Hopefully you can do them, and then I'll come back with the answers. So, complete combustion is any hydrocarbon, I'm just going to put alkane, plus oxygen, makes your energy, which you need to power your vehicles, but it also makes carbon dioxide and water. That's complete combustion. In complete combustion, you've still got your alkane. Okay, you've still got your oxygen, but say you've got half the amount, it's not enough. Okay, you still make energy, but say you make half the amount, that's not accurate, it's just for you to get into your head, you make less energy. And this time you make carbon monoxide, which is toxic, and your body thinks it's oxygen, so you can get carbon monoxide poisoning. Draw the fire triangle, nice and easy, three parts. Oxygen, fuel, heat. How would you stop a forest fire? Forest fire is a fuel aspect, so you could do a fire break. What are the benefits of hydrogen as a fuel? No CO2 released. And what are the inaccuracies of burning fuel experiment? Heat loss, water, temperature of the water, so the uneven spread. So the uneven spread, so heat loss, temperature of water, and the thermometer. You could use a digital thermometer. Okay, so like I've said before, if you get them all right, you know this topic, so you can move on to the next topic. If you don't, go back, watch the video again, and start again.